Imagine a machine, cold and blind, hurtling through an abyss so absolute it defies human comprehension. For nearly half a century, it has known nothing but the fading warmth of a dying star behind it and the infinite, crushing black ahead. It is a relic of the 1970s, powered by a decaying heart of plutonium, executing lines of code written by engineers who are now mostly long gone. This is Voyager 1. It is currently over 15 billion miles away from the pale blue dot that built it. To comprehend this staggering scale, you must discard your daily intuition. If you were to board a commercial airliner traveling continuously at its maximum cruising speed, your journey to Voyager's current location would take over 3,000 years of uninterrupted, relentless flight into the dark. For decades, the assumption among the brightest minds on Earth was simple and perhaps subconsciously comforting. We believed that as Voyager drifted further from the gravitational anchor of the Sun, the solar wind, the stream of charged particles our star exhales, would simply thin out. We imagined a gentle, asymptotic fading of our star's influence, a quiet transition into the peaceful, empty void of true interstellar space. We expected a gradual dissolve into a silent nothingness, but the universe is rarely gentle, and it is never peaceful. When Voyager finally pierced the outer boundary of our solar system, an invisible, titanic threshold known as the heliopause, it did not find the quiet emptiness we had meticulously modeled on our chalkboards. The probe's sensors, ancient but fiercely resilient, beamed back a stream of binary data that took nearly an entire day to reach the antennas on Earth, traveling at the absolute, unforgiving speed of light. When planetary scientists finally decoded those faint radio whispers, they uncovered a reality that shattered our fundamental models of the cosmos. Space was not getting emptier, it was getting thicker. Voyager had blindly slammed into a turbulent, high-density wall of cosmic radiation and magnetic pressure. The raw plasma of interstellar space was pushing back against our solar system, compressing the edge of our domain with a violent, crushing force. The physical state of this surrounding medium did not plummet toward the freezing stillness of absolute zero, as we logically assumed. Instead, the kinetic energy of the particles surged, simulating a chaotic inferno burning at tens of thousands of degrees. It was as if humanity's furthest and most fragile outpost had quietly navigated out of a calm harbor, only to instantly strike a roaring, invisible ocean of fire in the pitch dark. The void between the stars is not a vacuum, it is a storm. We are completely isolated in a hostile cosmos, insulated only by a fragile magnetic bubble, and we have just now touched the violent shore of the true cosmic ocean. If you seek to understand the terrifying architecture of the universe, and if you demand the unvarnished truth hidden in the dark, subscribe and join us on this journey. The turbulent boundary we just crossed is merely the outer skin of a much older, much darker mechanism at play. To understand the magnitude of this collision, we must first dismantle the way your brain is hardwired to perceive empty space. The human mind evolved on a small, rock-solid planet, enveloped by a dense blanket of atmospheric gas. Our entire cognitive framework is built upon the interaction of matter. We understand boundaries as physical, tangible things. A brick wall, a shoreline where the ocean meets the sand, the line where the forest gives way to the desert. When we look up at the night sky, our primitive intuition deceives us into believing that the dark gaps between the stars are simply places where things are not. We equate darkness with absence. We equate distance with a quiet fading away. For centuries, this terrestrial intuition heavily influenced even our most brilliant scientific minds. Early philosophers dreaded the concept of a true vacuum. They filled the void with imaginary substances, proposing an invisible stationary ether that permeated the heavens, simply because the idea of absolute nothingness was too unsettling to accept. Even as modern astrophysics stripped away these comforting illusions, leaving us with the terrifying reality of a hard vacuum, a subtle bias remained. We assumed that the influence of our sun, its light, its heat, its magnetic grip, would simply dissipate smoothly into the infinite dark, like the glow of a lone street lamp vanishing into a thick fog. We modeled the edge of our solar system as a peaceful, fading echo. This assumption was fundamentally dangerously flawed. The unlearning of this error began in the mid-20th century, driven by a radical shift in our understanding of what a star actually is. In the late 1950s, a young astrophysicist named Eugene Parker proposed a concept that was initially met with intense skepticism and outright mockery by the scientific establishment. At the time, the Sun was largely viewed as a static, glowing sphere of gas, held in a delicate, perfect balance by its own immense gravity. Parker looked at the mathematics governing the Sun's outermost atmosphere, the corona, and saw a disturbing imbalance. The mathematical equations describing the heat and pressure of the corona revealed a relentless, undeniable truth. The outer atmosphere of the Sun is simply too violently hot for the star's gravity to hold onto it. It cannot be contained. Parker realized that the Sun does not just radiate light, it boils over. It is locked in a state of continuous, omnidirectional detonation. He translated complex fluid dynamics into a terrifying conceptual reality. The extreme thermal energy of the corona forces the solar plasma to expand outward, accelerating to supersonic speeds. This is not a gentle breeze. It is a torrential, hurricane-force gale of ionized gas, protons and electrons, violently ejected into the void at speeds exceeding 1,000,000 miles per hour. It sweeps the inner solar system clean, blasting past the planets, carrying the Sun's twisted magnetic field along with it. Parker called this relentless outward explosion the solar wind. Because of the solar wind, the space between the planets is not empty. It is a dynamic, electrically charged fluid. This realization forced humanity to confront a new cosmic architecture. Our Sun is actively blowing an immense, invisible bubble into the dark. This bubble is called the heliosphere, and it contains all the planets, all the moons, every asteroid, and every human being who has ever lived. But a bubble cannot expand forever. The fundamental laws of geometry dictate that as the solar wind rushes outward, spreading across ever-increasing volumes of space, it must lose its density. It stretches thinner and thinner. Eventually, billions of miles away from the warmth of the inner system, the outward pressure of the solar wind must become so weak that it can no longer push back against the crushing weight of the outside universe. This brings us to the nature of the outside universe itself. The interstellar medium, the space between the stars, is not a pristine, empty void. It is a harsh, chaotic graveyard. It is filled with the cold, ancient ashes of dead stars, clouds of microscopic silicate dust, and chaotic magnetic fields generated by the slow rotation of the Milky Way galaxy. It is a pressurized environment, a vast ocean of thin but violent material drifting between the solar systems. Our entire heliosphere is not stationary. The Sun is hurtling through this interstellar ocean at roughly 500,000 miles per hour, dragging the planets along with it. Imagine a snowplow violently forcing its way through a blizzard in the dead of night. The bubble of our solar system is not a perfect, elegant sphere. It is distorted, stretched, and violently compressed at its leading edge, forming a blunt nose where we crash into the galactic tide, and a long, comet-like tail trailing behind us in the dark. The boundary where the dying breath of our Sun finally meets the crushing pressure of the interstellar ocean is known as the heliopause. For decades, scientists tried to calculate exactly where this boundary was and what it would look like. But they were modeling an environment no human artifact had ever touched, using physics derived from a cozy, dense planet. The intuition of the era suggested a smooth, gradual blending. Fluid dynamics, when applied to water or air on Earth, often show gentle mixing zones. If you drop a stone into a pond, the ripples fade into the stillness. Scientists assumed the solar wind would simply slow down, cool off, and quietly merge with the interstellar gas. They expected a quiet, freezing transition into the great dark. They equated the vast distance from the Sun with a plunge toward absolute zero, assuming that because there was less solar heat, the environment would be cold, sluggish, and dead. They forgot that plasmas do not behave like water. Plasma is a state of matter where electrons are ripped away from their atoms, creating a fluid completely enslaved by magnetic fields. When the electrically charged solar wind encounters the electrically charged interstellar medium, they cannot simply mix. The magnetic fields act as invisible, impenetrable walls The two environments are fiercely separate, locked in an eternal, invisible war of pressure. As the Voyager probes sailed deeper into the outer solar system, passing the orbits of Neptune and Pluto, the true violent mechanics of this boundary began to reveal themselves through mathematical deduction and sparse telemetry. The probes had left the realm of planets and entered a region of absolute isolation. Imagine walking through an immense abandoned metropolis at 3 in the morning. The silence feels absolute. You perceive it as empty, but the air is still filled with unseen radio waves, microscopic dust, and the faint hum of distant power lines. What you perceive as empty is just a limitation of your senses. The cosmos operates on a similar deception, but on a scale that shatters the mind. When a command is sent from Earth to Voyager in this deep void, it does not arrive instantly. The universe enforces a strict, unbreakable speed limit. The command crawls through the dark at the speed of light. It takes nearly 22 hours just to cross the distance. Imagine trying to monitor a fragile machine moving at tens of thousands of miles per hour, knowing that every piece of data you receive is a ghost from the past. You are forever observing a delayed reality. Through this staggering latency, scientists realized the boundary was not a gentle fade, but a series of violent physical shocks. The first anomaly was the termination shock. As the solar wind expands outward, it travels at supersonic speeds. But when it finally begins to feel the immense opposing pressure of the interstellar medium pushing back, it cannot simply decelerate smoothly. The physics of the collision dictate a violent, abrupt braking. The solar wind crashes into the invisible resistance and drops below the speed of sound almost instantly. Think of a torrential river suddenly hitting a narrow, rocky gorge. The water violently churns, heating up from the friction, piling onto itself. This is what happens to the solar plasma. At the termination shock, the particles compress. The magnetic fields twist and fold over themselves. The environment becomes a chaotic, boiling maelstrom known as the heliosheath. Voyager 1 hit the termination shock in late 2004. The data it sent back was the first real hammer blow to our terrestrial intuition. The environment did not quiet down. It became violently unstable. The spacecraft was suddenly flying through a region where the solar magnetic field lines were snapping, reconnecting and whipping around like frayed electrified cables. But this turbulent zone was still, technically, inside the sun's domain. It was just the wreckage at the edge of the bubble. The true boundary, the heliopause itself, still lay ahead in the dark. As Voyager pushed deeper through the churning heliosheath, scientists continued to harbor a fatal misunderstanding about temperature and density. It is here that common sense fails completely. In our daily lives, temperature is a measure of how densely packed molecules bounce off each other. A hot room is full of rapidly colliding air molecules. But in the near-perfect vacuum at the edge of the solar system, density is almost non-existent. There might be only a single atom in an area the size of a coffee cup. However, thermodynamics in a vacuum operates under a different, ruthless logic. The few particles that do exist in this region are not sluggish. They are being accelerated by complex magnetic forces to staggering, incomprehensible velocities. In the rigid mathematical definitions of physics, high velocity equals high kinetic energy. And high kinetic energy is strictly defined as high temperature. It is a terrifying paradox. You could freeze to death in a fraction of a second in the vacuum of space, while simultaneously being bombarded by individual particles burning at tens of thousands of degrees. It is the cosmic equivalent of a solitary, invisible bullet flying through a dark, freezing cathedral. It is sparsely populated, but carrying lethal, blistering energy. The researchers monitoring Voyager's fading signals expected the density of particles to slowly drop to nothing as the probe approached the final threshold. They expected the violent magnetic turbulence of the heliosheath to gradually smooth out into the quiet, pristine alignment of the galactic magnetic field. They expected to quietly slip out the back door of the solar system unnoticed. Instead, the archaic sensors on Voyager 1 began to register a buildup of pressure that defied all existing models. The plasma density was not dropping, it was compressing. The magnetic field was not smoothing out, it was piling up, growing stronger, folding into an impenetrable barrier. The mathematical models run on supercomputers back on Earth began to fracture under the weight of the incoming data. The edge of the solar system was not a fading echo. It was a pressurized barricade, held in place by forces we were only just beginning to comprehend. The thin, freezing void was, in reality, a boiling wall of cosmic radiation, and Voyager, flying completely blind in the dark, was accelerating straight into it. To comprehend the terrifying architecture of the boundary Voyager pierced, we must first look at the fragile, archaic machinery doing the measuring. Voyager 1 is a mechanical ghost. It is a 1-ton chassis of aluminum and titanium, powered by the slow, inevitable radioactive decay of a sphere of plutonium-238. It operates with a total computational memory that is less than a fraction of a single photograph on a modern smartphone. Yet it was tasked with deciphering the most violent and complex thermodynamic environment our species has ever encountered. By the time it reached the edge of the solar system, many of its primary sensory organs had long since rotted away, succumbing to the brutal absolute zero of deep space and decades of relentless radiation bombardment. The most critical loss occurred in 1980, just after the probe swung past Saturn. The plasma science experiment, the dedicated instrument designed to directly swallow and measure the density, temperature, and speed of the solar wind, simply died. It suffered a catastrophic hardware failure, leaving the spacecraft effectively blind to the very medium it was supposed to map. For decades, mission control at the Jet Propulsion Laboratory had to navigate the dark using only secondary senses, relying on indirect forensic evidence gathered by the surviving instruments. The burden of discovering the edge of our world fell to an instrument known as the plasma wave subsystem. Physically, it consists of two incredibly thin beryllium-copper antennas extending 10 meters outward from the main body of the spacecraft, forming a massive metallic V-shape. They act as the whiskers of a blind creature navigating a pitch-black cave. But they do not feel physical objects. They feel the invisible electric tension of the void. To understand what these antennas discovered, we must translate a deeply complex mathematical principle into a physical reality. Space is filled with plasma, a chaotic soup of electrons torn entirely away from their atomic nuclei. Because these electrons carry a negative electrical charge, they are extremely sensitive to any disturbance. If a shockwave passes through this plasma, the electrons are violently shoved out of their resting positions. But the heavier, positively charged protons nearby instantly exert a devastating electrostatic pull, snapping the electrons back. The electrons overshoot, get pulled back again, and begin to oscillate. They vibrate. The mathematics governing this interaction dictate an ironclad rule of the cosmos. The speed of this vibration, known as the plasma frequency, is strictly dictated by the density of the environment. If the plasma is thin, the electrons vibrate slowly, producing a low-frequency wave. If the plasma is densely packed, the restoring electrostatic force is monolithic, causing the electrons to snap back and forth with ferocious speed, producing a high-frequency scream. These vibrations cannot be heard by the human ear. They are electromagnetic waves, akin to radio signals. But the archaic processors on Voyager are designed to capture the mathematical blueprint of these waves, digitize them into ones and zeros, and hurl them billions of miles back to Earth, where engineers can translate that raw data into audio files. They listen to the vacuum. For 35 years, the pitch of the solar wind had been steadily dropping. As Voyager pushed deeper into the abyss, the density of the sun's breath thinned out, and the recorded pitch groaned into a low, sluggish rumble. The mathematical models predicted that as the probe finally crossed the heliopause and entered true interstellar space, this pitch would drop even further, perhaps silencing entirely into a cold, empty flatline. We expected the void to be hollow. In late August of 2012, the environment around Voyager 1 began to mutate. The transition was not a smooth fade, but a sudden, violent structural collapse of everything we understood about the local universe. The first anomaly was a microscopic avalanche of radiation. For decades, Voyager had been battered by a steady, predictable rain of low-energy particles generated by the sun. These particles are trapped within the heliosphere, bouncing around the inside of our solar bubble. Simultaneously, the sensors occasionally detected a different breed of radiation: galactic cosmic rays. These are not born in our sun. They are the heavy, shattered atomic cores of ancient stars that detonated in supernovae millions of years ago on the other side of the Milky Way. These high-energy subatomic shrapnel pieces streak across the galaxy at nearly the speed of light, carrying enough kinetic energy to rewrite DNA and fry circuitry upon impact. Throughout its journey, the sun's magnetic field had acted as a monolithic shield, deflecting the vast majority of these deadly galactic cosmic rays away from the inner planets and the fragile probe. But on August 25th, the data feed sent back to Earth displayed an impossible geometry. In a matter of days, the count of lower-energy solar particles simply vanished. They dropped by a factor of 1,000, seemingly wiped from existence. Simultaneously, the radiation counters screamingly spiked as the spacecraft was instantly flooded by a torrential downpour of high-energy galactic cosmic rays. The shield was gone. Scientists scrutinized the data, assuming the archaic instruments were finally experiencing fatal hardware degradation. But the telemetry was immaculate. Voyager had stumbled into a microscopic structural flaw in the cosmic architecture, a phenomenon astrophysicists later termed a magnetic highway. The sun's magnetic field, blown out billions of miles into the dark, had finally crashed against the sprawling, ancient magnetic field of the interstellar medium. But instead of bouncing off one another, the chaotic physics of magnetic reconnection took over. The invisible, twisted field lines of our solar system fractured and violently spliced themselves together with the magnetic field lines of the galaxy. This created a literal microscopic highway in the dark, an open conduit leading straight out into the interstellar abyss. The solar particles, trapped for billions of miles, instantly bled out through this puncture wound into the infinite void. And the heavy, radioactive shrapnel of the galaxy came pouring in. This alone was a monumental discovery. It proved Voyager had touched the outer skin of the bubble. But the grandest, most terrifying revelation was yet to come. The loss of the solar particles meant Voyager was now adrift in an entirely new fluid. But because the primary plasma sensor had died 3 decades earlier, scientists could not directly measure the density of this new environment. They knew Voyager was standing outside the door, but they could not feel the rain. They needed a shockwave to force the new environment to reveal its density. They needed a cosmic sonar ping. They waited for nearly a year in deafening silence. Then the sun provided the trigger. Months earlier, a colossal explosion had ripped across the surface of our sun. A coronal mass ejection, a titanic eruption of superheated plasma weighing billions of tons, was blasted outward into the solar system. This shockwave rolled past Mercury, washed over Earth, tore past the gas giants, and continued outward, fading as it expanded into the black. It took over a year for that dying tsunami to cross the 12 billion miles to reach Voyager 1. When the ghost of that solar explosion finally slammed into the interstellar medium surrounding the spacecraft, it acted like a hammer, striking an immense, invisible bell. The shockwave violently compressed the plasma of interstellar space, forcing the electrons to oscillate. The 10-meter antennas on Voyager caught the vibration, recorded the frequency, and beamed the data back across the abyss. When researchers at the University of Iowa translated that data, they did not hear the low, sluggish rumble of an empty void. They heard a high-pitched, screaming oscillation. The mathematics derived from that frequency were undeniable and horrifying. The calculation revealed that the plasma Voyager was flying through was not thinner than the solar wind. It was astronomically thicker. The density of the interstellar medium, the supposedly empty, freezing void between the stars, was 40 times greater than the density inside the outer heliosphere. The numbers dictated a reality that broke human intuition. The space immediately outside our solar system is not a sprawling empty vacuum. It is heavily compressed. The magnetic field of the galaxy is bearing down on our tiny bubble of warmth with a crushing, unfathomable weight. The material out there is cold, but it is packed together with violent force, creating a dense, pressurized ocean of ancient stellar wreckage. This density spike pointed toward a terrifying cosmic structure that astronomers had theorized but never touched: the hydrogen wall. To visualize this, you must abandon the idea of solid objects. Think of a massive river pouring out of a dam, crashing into the heavy, dark water of a deep ocean. The solar wind, rushing outward at supersonic speeds, consists entirely of ionized plasma. The interstellar medium pushing back consists heavily of neutral hydrogen atoms, cold, ancient gas that has drifted between the stars since the dawn of the universe. When these two completely different environments collide at the heliopause, a chaotic atomic war breaks out, governed by the cold rules of charge exchange. As a high-speed ionized proton from the sun violently smashes into a slow, cold, neutral hydrogen atom from interstellar space, the solar proton rips the electron away from the ancient atom. The physics of this theft result in a staggering transformation. The cold interstellar atom becomes charged, getting violently swept up and accelerated by the magnetic fields. But the fast-moving solar proton, having stolen an electron, suddenly becomes electrically neutral. Because it is no longer bound by the magnetic cage of the solar system, it simply ignores the magnetic fields and shoots straight outward into the galaxy like a microscopic ballistic missile. This continuous trillion-fold atomic collision creates a buildup of material. The slow interstellar gas piles up against the leading edge of our solar system, unable to easily penetrate the magnetic shield. It compresses. It heats up kinetically. It forms a literal glowing wall of neutral and ionized radiation that stretches for billions of miles across the nose of the heliosphere. Voyager 1 did not just drift into an empty night. It bored a hole straight through a monolithic, pressurized barricade of cosmic radiation and piled up atomic debris. We are trapped inside a microscopic bubble, surrounded by a glowing, suffocating wall of heavy matter, relentlessly crushed by the immense weight of the galactic tide. And as astrophysicists pored over the density data, a cold realization set in. The math describing this wall was deeply, inherently flawed. The sheer density of the plasma Voyager was measuring could not be accounted for by the simple pressure of the interstellar medium alone. There was a missing variable in the equations. Something massive, something possessing an unimaginable kinetic force, was pressing against the heliopause from the outside, injecting energy into the system that we could not see. The wall was not just thick, it was being actively compressed by a ghost force that violated the existing laws of thermodynamic equilibrium. The architecture of the universe is built upon a foundation of absolute, unforgiving mathematical balance. In the realm of theoretical astrophysics, this balance is dictated by a fundamental principle known as pressure equilibrium. It is the invisible ledger that governs the mechanics of the cosmos. Whether you are observing the slow collapse of a nebula, the violent accretion disk swirling into the maw of a black hole, or the massive glowing arms of a spiral galaxy, the mathematics demand that the pressure pushing outward must always be precisely matched by the pressure pushing inward. If the ledger is unbalanced, the system collapses or violently explodes until equilibrium is restored. For decades, the brightest minds on Earth applied this ironclad mathematical law to the edge of our solar system. They mapped the outward kinetic force of the solar wind, calculated the faint magnetic tension of the distant sun, and balanced those numbers against the estimated weight of the interstellar void pressing back. The equations were elegant. They formed a neat, closed loop on the chalkboards of universities across the globe. But when the archaic sensors of Voyager 1 finally plunged into the dark and beamed the raw, unfiltered data of the boundary back to Earth, that mathematical ledger was torn to shreds. The numbers sent back by the probe dictated a physical impossibility. The density of the interstellar plasma crashing against the nose of our solar system was far too high, and the magnetic field of the galaxy was unimaginably stronger than any theoretical model had permitted. When astrophysicists plugged Voyager's telemetry into their pressure equilibrium equations, the math violently fractured. The crushing weight of the outside universe was astronomically greater than the outward pressure our dying solar wind could exert. According to every known law of fluid dynamics and thermodynamics, our heliosphere should not exist. The immense pressurized ocean of the Milky Way should have instantly crushed our tiny, warm bubble inward, collapsing the boundary back past the orbits of Neptune, Uranus, and perhaps even Jupiter, bathing the inner planets in lethal high-energy stellar radiation. Yet, the boundary holds. The bubble remains intact. This presents a terrifying paradox that has paralyzed modern astrophysics. If the outward pressure of the Sun is completely insufficient to hold back the crushing density of the interstellar medium, then there must be a missing variable in the equation. Something invisible, possessing an unfathomable amount of kinetic or thermal energy, is pushing back from the inside, propping up the outer wall of our solar system against the sheer monolithic weight of the galaxy. To find this missing ghost force, scientists turn to the most complex mathematical frameworks ever devised by our species: the equations of magnetohydrodynamics. This is the brutal, unforgiving mathematics of electrified fluids. It attempts to map a chaotic, multi-dimensional reality where physical matter is entirely enslaved by invisible magnetic fields, where the movement of a single electron alters the magnetic tension of the entire system, and where that altered tension instantly snaps back to dictate the movement of the fluid. It is a mathematical Ouroboros, a serpent eating its own tail, creating a chaotic feedback loop that requires the largest supercomputers on Earth months of continuous processing just to simulate a tiny, microscopic fraction of the boundary. When researchers fed Voyager's impossible data into these supercomputers, attempting to model the collision between the heliosphere and the interstellar medium, the algorithms began to break down under the weight of catastrophic asymmetry. In controlled environments, fluid dynamics make sense. When two similar fluids collide, their interaction is predictable. But at the edge of the solar system, the universe forces two entirely alien architectures of matter into a violent, face-to-face collision. On the inside of the boundary, you have the solar wind, an incredibly sparse, blisteringly hot fluid composed entirely of ionized plasma, where every particle carries an electrical charge. On the outside, pressing in, you have the interstellar medium, a vast, heavily compressed ocean that is a chaotic mixture of both ionized plasma and cold, dead, neutral hydrogen gas that has drifted through the dark since the birth of the galaxy. When you attempt to run the magnetohydrodynamic equations to calculate the friction, the thermal exchange, and the magnetic resistance between these two profoundly different environments, the mathematics simply shatter. The equations cannot resolve the sheer aggressive gradient of density and temperature. The collision is too violent, the difference in atomic makeup too extreme. The supercomputers, programmed to find harmony and equilibrium, output pure, unadulterated noise. The macro physics of fluid dynamics break down, forcing physicists to look deeper, plummeting into the maddening microscopic realm of kinetic theory. Kinetic theory forces you to abandon the idea of a fluid altogether and look at the terrifying reality of the void. Space is not a liquid. It is a dark room filled with isolated, hyper-accelerated bullets. To understand the missing pressure holding our solar system open, scientists tried to model the exact chaotic flight path of billions of individual protons and electrons as they slammed into the cold hydrogen atoms of deep space. They were looking for the spark, the exact moment of particle collision that might explain the immense hidden energy holding the wall in place. Instead, they found a phantom engine that violates our fundamental understanding of particle acceleration. This brings us to the profound mystery of anomalous cosmic rays, one of the most frustrating and humbling puzzles in modern astronomy. For 30 years, standard textbooks declared that the termination shock, the inner boundary where the supersonic solar wind violently slams on the brakes, was a massive, ring-shaped particle accelerator. The theory was beautifully logical. The math showed that when a shockwave of that magnitude ripples through plasma, it traps slow-moving particles, bouncing them violently back and forth across the magnetic boundary. With each bounce, the particle steals kinetic energy from the shockwave, accelerating exponentially until it is moving at a significant fraction of the speed of light. These hyper-accelerated bullets, stripped of their electrons, are then hurled inward toward the planets. We called them anomalous cosmic rays, and we were absolutely certain we knew exactly where and how they were forged. We were completely wrong. When Voyager 1 blindly drifted through the termination shock in the mid-2000s, its instruments were primed to witness this massive cosmic engine in action. It was supposed to fly straight through the fiery heart of the particle accelerator. The mathematical models predicted a massive, unmistakable spike in the intensity of anomalous cosmic rays, peaking exactly at the shockwave. But as the archaic probe crossed the threshold, the sensors recorded something utterly terrifying. Nothing happened. The predicted spike was entirely absent. The anomalous cosmic rays were still there, washing over the spacecraft in lethal waves, but they were not peaking. The termination shock was completely quiet. It was not accelerating anything. The cosmic engine we had mathematically proven to exist simply was not there. The brightest minds on the planet stared at the telemetry in disbelief. Voyager had proven that the massive radiation engine bombarding our solar system was not located where the fundamental laws of shockwave physics demanded it must be. If these particles are not being accelerated at the termination shock, then they must be generated further out, deep within the dark, boiling maelstrom of the heliosheath, or perhaps even at the very edge of the heliopause itself. But the math of the heliosheath offers no viable mechanism for this level of extreme acceleration. The environment is too chaotic, the magnetic fields too twisted, the thermal gradients too messy to support the elegant bouncing acceleration model we relied upon. We are faced with a sprawling field of hyper-lethal radiation, and we are completely blind to the machine that is firing it. This total failure of kinetic theory and fluid dynamics has forced astrophysicists to propose models that sound less like science and more like structural horror. If the boundary is not a smooth, mathematically predictable shield, and if the standard equations of magnetic collision fail so spectacularly, then the architecture of the edge must be fundamentally broken. The current, desperate hypothesis attempting to bridge the gap in our mathematics suggests that the heliopause is not a solid wall nor a gentle fade. It is theorized to be a macabre, boiling region of magnetic foam. To visualize this, you must understand the terrifying mechanics of magnetic reconnection. When the invisible magnetic field lines of the Sun are blown outward into the crushing pressure of the interstellar medium, they cannot simply slide past the magnetic field of the galaxy. They snag, they twist. The immense opposing forces stretch the invisible lines of magnetic tension until the mathematics of structural integrity fail. The field lines violently snap, releasing explosive bursts of thermal energy, and then immediately rewire themselves into chaotic new shapes. Because of the catastrophic asymmetry of the plasma, the hot, sparse inside crashing against the cold, heavy outside. This magnetic snapping does not happen uniformly. It happens in violent, unpredictable clusters. The math suggests that the outer skin of our solar system is constantly tearing itself apart and stitching itself back together, creating colossal, isolated magnetic bubbles. Each of these invisible bubbles stretches over 100 million miles across, detaching completely from the Sun's primary magnetic network and tumbling blindly into the crushing dark of the interstellar ocean. This magnetic foam theory offers a chilling explanation for the missing pressure and the phantom particle accelerators. These disconnected, 100-million-mile-wide leviathans of twisted magnetic force act as perfect, inescapable traps. When lethal cosmic rays drift into these bubbles, they are locked inside. The chaotic, snapping magnetic fields within the foam violently whip the particles back and forth, accelerating them to terrifying speeds in complete darkness, acting as millions of isolated, invisible radiation engines churning away at the edge of our world. The combined violent thermal energy of this boiling foam might be the missing variable, the immense ghost force pushing back against the crushing weight of the Milky Way, preventing the immediate collapse of the heliosphere. But even this terrifying model leaves scientists deeply unsettled, because the fundamental equations of magnetic reconnection are still producing errors. Our math is too pristine, too logical to fully capture the sheer, indifferent brutality of the cosmos. We are trying to measure a raging cosmic hurricane with a wooden ruler, and as the supercomputers continue to fail, crunching numbers that spiral into impossible infinities, a darker, more immediate realization has emerged from the continuous stream of faint, binary whispers sent back by the Voyager probes. The barrier separating us from the true ancient dark of the universe is not a static line drawn on a stellar map. The failure of our mathematical models is partly due to our assumption of permanence. We modeled the heliosphere as a rigid, enduring structure. We assumed the pressure from the outside galaxy was a constant, unyielding force. But the interstellar medium is a living, turbulent ocean governed by the ghosts of long-dead stars. Millions of years ago, colossal stars in our local galactic neighborhood exhausted their nuclear fuel and violently detonated in supernovae, sending titanic shockwaves of heavy matter and twisted magnetic energy rippling across the Milky Way. These ancient tsunamis of cosmic wreckage are still rolling through the dark, slowly crossing the incomprehensible distances of the galaxy. Voyager's data heavily implies that our solar system is currently sailing through an environment that is shifting. The immense pressure bearing down on the heliopause from the outside is not uniform, and it is not static. The invisible wall is breathing. The crushing weight of the interstellar ocean ebbs and flows, and as the external pressure surges, the delicate, unexplained equilibrium at the edge of our world buckles. The barrier is actively reshaping itself, compressing inward and bowing outward, an organic, colossal membrane reacting to the invisible tides of the galaxy. And the mathematics, struggling to hold on to reality, suggest that the crushing weight of this ocean is currently pressing harder, pushing the violent, boiling boundary of our isolated bubble closer to the inner planets. The realization that our solar system is encased in a shifting, boiling membrane of magnetic foam fundamentally rewrites our understanding of our place in the universe. We have long operated under the comforting delusion that the cosmos is a static, unchanging backdrop to human history. We view the positions of the stars and the boundaries of our system as permanent geographical facts, much like the continents on Earth. But the data whispered back by the dying sensors of Voyager one shatters this illusion of permanence. It reveals that our reality is dictated by galactic weather patterns operating on a timescale so vast and with forces so violent that human comprehension begins to fracture. The boundary of our world is not a line drawn in the dark. It is a war zone, and the front line is moving. If the heliopause is an organic breathing barrier, bowing inward under the crushing weight of the interstellar ocean, we are forced to confront a deeply unsettling consequence. The protective bubble that shields the inner planets is not guaranteed. To understand the existential threat this poses, we must look at what exactly the heliosphere is protecting us from. As we established, the space outside our solar bubble is flooded with galactic cosmic rays. These are not rays of light. They are the physical shattered cores of heavy atoms, iron, nickel, and carbon, ejected from the catastrophic detonations of dying stars, thousands of light years away. They are accelerated by the shockwaves of supernovae to velocities that approach the absolute speed limit of the universe. The mathematics of relativity dictate a merciless consequence for objects moving this fast. As an atomic nucleus accelerates toward the speed of light, its mass and kinetic energy increase exponentially. A single microscopic iron atom traveling at these relativistic speeds carries the kinetic force of a heavy lead projectile fired from a rifle. Now imagine a continuous invisible hurricane of this subatomic shrapnel sweeping across the galaxy. Currently, the vast outward-pushing magnetic field of our Sun deflects roughly 70% of this lethal radiation before it can reach the orbit of Earth. Our planet's own delicate magnetic field catches most of the remaining fragments. We exist in a deeply sheltered, quiet harbor. But the universe is a fluid, dynamic engine. Our Sun is not sitting still. It is hurtling around the center of the Milky Way galaxy at over 500,000 miles per hour, dragging the planets along on a 250 million-year orbit. As we sail through the dark, we drift through different regions of the galactic environment, much like a ship passing through patches of fog, heavy storms, and clear waters. Astrophysicists analyzing the density of the interstellar medium, mapped by Voyager, have realized that we are currently approaching a denser, heavier region of the cosmic ocean. We are sailing into an ancient, massive cloud of interstellar gas, known as the local interstellar cloud. As the Sun plows deeper into this dense material, the immense pressure pushing against the nose of the heliosphere will inevitably increase. The mathematics of fluid dynamics, even in their broken state, promise one undeniable outcome. When the outside pressure rises, the bubble shrinks. If the external density becomes severe enough, the violent boiling boundary of the heliopause will be crushed inward. It could be pushed back past the orbits of Neptune, past Uranus, perhaps even collapsing past the orbit of Jupiter. If the outer barrier falls, the inner solar system will be violently flooded by the unfiltered primordial radiation of the deep galaxy. We do not have to guess what happens when the solar shield fails. The universe has already left forensic evidence of past collapses buried directly beneath our feet. Deep at the bottom of the Pacific Ocean, locked within ancient layers of geological crust, scientists have discovered a terrifying anomaly. They found microscopic traces of an isotope known as iron-60. This specific radioactive material cannot be created by normal geological processes on Earth, nor is it produced by our Sun. The rigid laws of nuclear physics dictate that iron-60 is forged exclusively in the heart of a massive star during the final apocalyptic seconds of a supernova detonation. The presence of this isotope in the oceanic crust, dating back roughly 2 to 3 million years, tells a haunting story. It means that during the early dawn of hominid evolution on Earth, the protective bubble of the heliosphere was completely breached. Our solar system drifted through the dense, highly radioactive wreckage of a detonated star. The crushing pressure of the supernova shockwave collapsed the Sun's magnetic shield, and for hundreds of thousands of years, the Earth was directly exposed to the raw, violent storm of the interstellar medium. The radioactive shrapnel of a dead alien star rained down through our atmosphere and settled into the dark depths of our oceans. If such a collapse were to happen today, the consequences would be mathematically catastrophic. You must discard the Hollywood image of glowing green radiation. A flood of galactic cosmic rays is an invisible, silent dismantler of complex chemistry. When these hyper-accelerated heavy atomic cores slam into the nitrogen and oxygen molecules in Earth's upper atmosphere, they do not just pass through. They shatter the atmospheric molecules upon impact, triggering a massive, cascading nuclear chain reaction in the sky. One cosmic ray strikes an atom, shattering it into a shower of secondary particles, muons, neutrons, and gamma rays, which then strike other atoms, creating an expanding cone of destructive energy plunging toward the surface. This continuous subatomic bombardment would systematically dismantle the ozone layer. The chemical bonds of the atmosphere would be ripped apart faster than they could reform. Without the ozone layer, the raw, searing ultraviolet light of our own sun would sterilize the surface of the planet. Furthermore, the sheer volume of cascading secondary radiation reaching the ground would cause an exponential spike in cellular mutation. It would be a slow, quiet, invisible erasure of the biological equilibrium we rely upon. We are a fragile species that evolved during a rare, temporary period of cosmic calm. We are not built to survive the true weather of the galaxy. But the shifting boundary of the heliosphere conceals an even darker consequence, one that strikes at the very heart of human ambition. For over a century, we have looked up at the stars and assumed that it was only a matter of time and technology before we built ships capable of crossing the great dark. We view the space between the stars as an empty highway, waiting to be traveled. Voyager's data acts as a brutal mathematical sobering. The true interstellar medium is not an empty highway. It is an incredibly dense, highly pressurized fluid filled with boiling magnetic foam, lethal radiation, and ancient stellar debris. The empty void is a fatal misconception. If humanity ever manages to build a vessel capable of traveling at a significant fraction of the speed of light, a necessity to cross the light years between stars within a human lifetime, that vessel will have to crash head-on into the wall Voyager just measured. Here, the physics of high-speed travel become our enemy. When you move slowly through a fluid, it gently parts around you. But when you accelerate to relativistic speeds, the fluid behaves like solid concrete. If a theoretical generation ship were to sail into the interstellar ocean at 10% the speed of light, it would not be traveling through empty space. It would be violently plowing through a highly pressurized soup of hydrogen atoms and twisted magnetic fields. At that staggering velocity, the gentle, ancient dust drifting between the stars transforms into lethal artillery. The proportion of kinetic energy dictates that colliding with a single grain of interstellar silicate dust, no larger than a grain of sand, while traveling at a fraction of light speed, releases the equivalent explosive energy of a tactical nuclear warhead. The ship's hull would be subjected to continuous devastating friction. The raw hydrogen gas of the interstellar medium would slam into the leading edge of the vessel, instantly heating the metal to millions of degrees, acting like a cosmic blowtorch attempting to vaporize the intruder. To survive this, a spacecraft would require shielding of unimaginable thickness and mass. But in the ruthless mathematics of orbital mechanics, mass is the ultimate penalty. The heavier the shield, the more energy required to accelerate the ship. The more energy required, the more fuel you must carry, which adds more mass, demanding even more energy. It is a terrifying, inescapable spiral of mathematical impossibility. The boiling barricade at the edge of our solar system and the dense, radioactive ocean beyond it suggests a chilling reality about the architecture of the cosmos. The universe is not designed for transit. The distances between the stars are not just vast measures of empty miles. They are heavily fortified, highly pressurized quarantines. The environment itself is profoundly hostile to the movement of complex biological life. We are forced to confront the possibility that the boundaries drawn by the sun's magnetic field are not merely the edges of a map. They are the walls of an absolute, inescapable cell. The stars we see in the night sky are not destinations waiting to be claimed. They are isolated burning islands, eternally cut off from one another by a roaring invisible ocean of lethal energy and suffocating density. The data pulsing weekly from Voyager 1, 15 billion miles in the dark, is not an invitation to explore. It is a stark mathematical warning that we are trapped in a fragile temporary pocket of calm, entirely at the mercy of forces we cannot see, cannot control, and are only just beginning to fear. The architecture of the heliosphere is not merely a physical barrier. It is a psychological mirror, reflecting our ultimate insignificance. For the entirety of human history, we have gazed upward into the infinite canopy of the night sky and projected our own profound need for meaning onto the scattered ancient light of distant stars. We connected the dots to form gods, heroes, and monsters. We built monuments of stone and steel, fought bitter wars over imaginary lines drawn on dirt, and convinced ourselves that our existence was the pinnacle of some grand cosmic design. We assumed that the universe was a stage built specifically for our performance, and that our intellectual triumphs somehow commanded the respect of the void. The fading binary whispers bleeding back from the abyss, 15 billion miles away, methodically dismantle that comforting arrogance. The telemetry does not describe a welcoming, silent frontier waiting for our arrival. It maps a terrifying, mechanized slaughterhouse of atomic energy. We are not the favored children of a benevolent cosmos. We are a fleeting biological accident clinging to a microscopic fragment of wet rock. We are insulated only by the dying magnetic breath of a solitary star, tumbling blindly through a roaring ocean of lethal radiation and the scattered, freezing corpses of ancient solar systems. The violent, boiling barricade that holds back the dark does not exist to harbor us. It is merely the unthinking consequence of absolute thermodynamic law, a momentary mathematical glitch of pressure and friction that happens to provide a temporary shadow where complex chemistry can briefly hallucinate that it matters. Voyager 1 is currently carrying our greatest hopes strapped to its decaying side. The golden record, carrying the sounds of our rainstorms, the voices of our children, and the geometry of our anatomy, was hurled into the deep as a desperate plea for recognition. It was cast out into the cosmic sea, driven by the profound, lonely desire to be known. But the ruthless architecture of the interstellar medium guarantees a much darker, much colder fate for our monument. It is sinking into a screaming maelstrom of relativistic shrapnel and heavy, ancient dust. Long before it drifts anywhere near the gravity of another star, the brutal, unyielding friction of the dark will pit, erode, and eventually sandblast that golden surface down to nothing. Our greetings, our music, the very proof that we ever existed. It will not be intercepted by a waiting intellect. It will be silently, methodically erased by the indifferent grinding of a hostile universe. We are screaming into a cosmic hurricane, and the hurricane cannot hear us. When you stand outside tonight and stare into the gaps between the stars, you must abandon the illusion of peace. The darkness is not empty. It is a suffocating, hyper-pressurized ocean of absolute violence. The faint, twinkling light reaching your retinas is nothing more than the exhaust of a terrifying cosmic engine that operates without purpose, without morality, and absolutely without mercy for the fragile flicker of human consciousness. There is no grand destination written in the heavens. There is no waiting salvation. There is only the thin, invisible membrane holding back the crushing weight of the galaxy and the infinite, patient dark, quietly waiting for the fire of our sun to finally burn out.